All right, hi, Math11. Your first uh, assignment or exam was the take-home exam that I'd given you on Tuesday. So try to get that in if you haven't already done so. I think about half of you have gotten that in. Try to get that in before the weekend, and then I'll try to mark it over the weekend and let you know the results for Tuesday's class. Okay, so let's try to get that in. And most of you seem to be doing good with the technology, right? Just write down the answers. Either print out the sheet of the take-home exam and write them in the space provided, or just write the answers on a separate sheet of paper, and then you can just take a picture of it and then and then submit that in the assignment section. Okay. So I've got a notes package that I'd like you to print out. If you don't have a printer or are unable to print it out, again, just write this down on a separate sheet of paper. So these are the notes for the next unit, and then I'll give you a take-home quiz on the stuff that we're covering tonight for Tuesday's class. Okay, so we just finished looking at radicals, so now we're going to switch gears and look at rational expressions. So a rational expression is basically something that you can write out as a fraction with a numerator and denominator that are polynomial. So numerator is the top part of the fraction, denominator is the bottom part of the fraction, and a polynomial, poly means many, is simply some type of expression that can contain variables. Okay, so like examples here, 2 over 3x or negative 3x over 4x squared plus 1, right? So this 3x would be a monomial, this 4x squared plus 1 would be a binomial. Okay, so those are examples of polynomials. Just like before, we do have some restrictions. Another way to describe our restrictions is we describe it as a non-permissible value. So non-permissible value simply means what the variable, so like in this case x, what it cannot be, right? So for this one here, x could not be equal to 0 because that would make the bottom of the fraction 0, the denominator equal to 0. So here's some examples. Determine the non-permissible value for each of the rational expressions. So this first one here, we would say b can't equal 0, c can't equal 0. Okay, and so that's what this means. It means it's not equal to. So these would be considered the non-permissible values. Again, it's the same thing as a restriction. Here, you've got the set of brackets here. So if this first set of bracket is equal to 0, then whatever this is irrelevant. It'll become 0 when it's anything that's multiplied by 0 becomes 0. So what you want to figure out is what makes the first bracket 0 and what makes the second bracket 0. Okay, so the first bracket becomes 0 if x is negative 2, and the second bracket becomes 0 if x is equal to 3, right? 3 minus 3 becomes 0. So again, these are your non-permissible values. Now for this one, it's not obvious what it is going to be. So when we are in this type of situation, what we want to do is factor. And if you identify what that is, that's a difference of squares. So remember, a difference of squares, that's where you've got a squared minus b squared. That's always equal to a minus b, a plus b. Okay, so that's your difference of squares. So y squared minus 4 is going to be y minus 2, y plus 2. Okay, so what that is saying is we could change this fraction to 2y squared over y minus 2, y plus 2. Okay, and so again, you don't want to make either of those 0, so that your restriction or your non-permissible values are y cannot equal 2 or negative 2. Now, what we did here is, in a way, we kind of simplified the expression here to this one. And so one of the things that we'll be doing is we'll be simplifying expressions, and whenever you have the same thing that's on the bottom as the top, then you can cancel it out. Okay, and so let's look at some of the questions like that. So like for example, this one here. Okay, so you've got, here's your numerators on the top, your denominators on the bottom. So what we'd first want to do is factor both of these. Okay, so if we factor both the top and the bottom, okay, so there's the top, right? So just remember, there's two numbers that add up to the middle, so that would be 1, and multiply to the end. So 2 times 10, negative 10, so negative 20, right? So positive 5 and negative 4 add up to 1, and then multiply to negative 20. Okay, so that factors to this. And then we do the same thing with the bottom, two numbers that add up to 3, multiply to negative 10, so positive 5 and negative 2. And that factors out to this. Okay, so now what we can do is we can take the existing fraction and replace those quadratic expressions, and we can change this to the factored form. Okay, and so now here's your top and the bottom, and you notice you've got a y minus 2 on both the top and the bottom, so that can be canceled out, and so this then becomes your simplified form. Okay, and so now when we do our non-permissible values, it's whatever the bottom was. So y can't equal negative 5. Notice even though we canceled this one out, we still have to have the restriction or the non-permissible value for it. Okay, so this one, a lot of times students forget to put this one in because it's not in the final answer. So you have to look at any steps along the way, even though something may be canceled out, and you still have to supply a non-permissible value for that. Okay, here's another one. Okay, so you've got 6 minus 2m, m squared minus 9. So again, there's a difference of squares. Okay, now, so we factor a 2 from 6 and negative 2. And so that gives us 3 minus m. And here we've got m minus 3 and m plus 3, right? Difference of squares. So what you notice here is they're not the same, right? Now, when you get into a situation like this, what we basically want to do is we want to change this so the 3 becomes negative and the m becomes positive, right? So negative, we want to change this to negative 3 plus m, right? And so we can do that if instead of having this a positive 2, we make that a negative 2. And negative 3 plus m, that's the same thing as m minus 3, right? If you just switch the order for that. So we can do that. So we change that to negative 2. And so now we have negative 2, m minus 3, m minus 3, m plus 3. Those can cancel out. And that's our answer. And then here's your restriction, right? So m can't equal 3 and negative 3, right? Again, the 3 is from the thing that you canceled out. Okay, here's another one. Now this one's a little bit different. So first it says, what you notice is you've got two different variables. We got x and y, and it's asking you what is a non-permissible value for y if x equals 3. So what you do is you substitute x equals 3 for the denominator, and that'll give you 8 times 3 minus 6y, or 24 minus 6y. You don't need to worry about the numerator, because if you're looking for a non-permissible value, we just care about the bottom part. And so if it's 24 minus 6y, then y can't be 4. Right? If y is 4, 6 times 4 is 24, 24 minus 24 is 0. So then this becomes a non-permissible value. Again, notice I didn't substitute for the top part. Next one here is just saying to evaluate the expression for these two values. X is 1.5, y is 2.8. So now in this case here, you're going to have to substitute into both of them. Okay, so you substitute 1.5 for x and 2.8 for y, and then you just basically sub that in and solve for each of those, and then because you're getting decimal answers, you can just write it out as a decimal answer. Okay, so that's the first section. Let's look at the second section. Okay, if you want, like at this point, you can stop here and then work on the first set of questions, and then you can continue the YouTube link to look at the second part of the lesson. So like this is what we would cover before the break, and then this second topic there is what we'd cover after the break. Okay, so we're looking at multiplying and dividing rational expressions. So when we multiply fractions, right? So let's say we multiply 2 over 5 by 3 over 7. So when we multiply fractions, the tops always multiply and the bottoms always multiply. Okay, and so the same is true here. Now, one of the things you can do is if you notice the top of one fraction is the same as the bottom of the other, then that's the same thing as if they're both coming from the same fractions. So you can cancel it out, just like we were doing with the simplifying. Okay, so here's your non-permissible values. So you can write these out at the front end if you want here. So r can't equal to 0 and d can't equal to 2. Pi is a value, so it's not a variable. Okay, so what you do is you look at these two fractions. You've got a 2 pi r at the bottom of this one, and you have a 2 pi r at the top of this one. So even before I multiplied out, just by noticing they're the same, I can cancel out. And it's always easier if you cancel out first, then there's basically less left over to multiply. So those two are gone. The d stays, the h stays, and the d minus 2 stays. So you get dh over d minus 2. Okay, here's another one. So first thing is you can factor everything. Okay, so you've got a difference of squares over here, y squared minus 9, so that becomes y minus 3, y plus 3. R squared minus r, you can factor out an r, you get r minus 1. You've got the y plus 3. And then here you've got r, you factor out r, so you're left with r squared minus 1. So there's an r, there's an r. Okay, so again, you're looking for something that's the bottom of one, the top of another, and they can cancel out. Y plus 3, that can cancel out. Now this r squared minus 1, you might notice that's also a difference of squares. So you can factor that out to r minus 1, r plus 1. And so the r minus 1 here is going to cancel out with the r minus 1 from this one. And so now all you're left with is y minus 3 and r plus 1. Okay, and then in terms of what the restrictions are, so r can't equal 1, right? R can't equal negative 1, and I missed one here. R can also not equal 0, right? Because of this r that's out over here, right? So that if that's 0, then the whole thing becomes 0, and then y can't equal negative 3 because of this one here. Okay, now dividing is a little bit more complicated. When you divide rational expressions, you have to multiply by the reciprocal, right? So for example, if I've got 2 over 5 divided by 1/3, right? So what I have to do is the reciprocal means that the fraction that you're dividing by has to be flipped over, and then this changes to a multiplication. So this is going to equal 2 over 5 multiplied by 3 over 1. Okay, so see how the 1/3 becomes 3 over 1. It flips over, and then the division becomes a multiplication. So this is going to equal 6 over 5. Okay, so that's how we do division when we're talking about fractions. So same thing here with the polynomials. So right off the bat, you see what I've done is I've changed this to a multiplication from a division, and this fraction here I've flipped over. Now I still have to consider this, even though it's flipped over, I still have to consider this part here for the non-permissible, even though it's become flipped over, because originally it was written in that way. Okay, so again, anything that any fraction, you have to consider the bottom part for the non-permissible values. Okay, so there we've changed it. It's been flipped over, and so now I've factored everything. Okay, so I factored c squared minus 6c minus 7, so that's c plus 1, c minus 7. Difference of squares here, c minus 7, c plus 7. This one, a c comes out, so it's c plus 7, and then this one factors out to c plus 1, c plus 7. So again, we can cancel things out here. So c plus 7 cancels out with this c plus 7. C minus 7 cancels out with this c minus 7. And the c plus 1 from the first fraction cancels out with the c plus 1 from the second fraction. So all you're left with is this c, and then this c plus 7. So there's your answer. And then as far as restrictions go, you've got c can't be equal to 7 because of this one. It can't equal negative 7 because of this one. It can't equal negative 1 because of this one. And it can't equal to 0 because of this one, which was originally over here. Over here. Okay. Okay, and then the last one here. So, I mean, this is a little bit a tougher question. So again, you can factor everything out. This one gets flipped over, and then it gets changed to a multiplication. Okay, so we got x plus 4, and then this 2x minus 6 becomes 2x minus 3. And so here, what you notice is after we factor it out, nothing cancels out. So you keep everything. You've got 3 times 12, which is 36. And then you've got this 2 over here. And so that 36 over 2 becomes 18. Okay, and so you can write your answer like this. Or if you want, you can square root the whole thing. And then this is just going to be equal to, so if you square root the whole thing, this just becomes root 18 over x plus 4, 3x plus 4, and x minus 3. Okay, so you can kind of, that's equivalent. And then again, here's your restrictions. Okay, so I'll stop there. So you can do these questions here. So page 317 is for the simplification questions, and then page 327 is for the multiplication and the division type questions. So same as before, and some of you are doing this, which is great. Go through these questions. Okay, you don't need to submit them. Okay, so this is just for your own practice. And then let me know which of these questions you'd like me to go over, and I'll begin Thursday's class by going over any of the questions you'd like me to address. And then I'll do the new topic. And then I'll also have a take-home quiz for you that's on this material. Okay, so again, make sure you get the tests submitted to me, and keep sending me any questions that you have. Okay, so the communication is starting to get really good. I am hearing from a lot of you, which I like. So just keep throwing the questions at me. A lot of you have already found out what your exam mark was prior to spring break. If you haven't sent a message to me about that, just send me a message and I'll let you know what your score was. Okay, so I'll stop here. Again, let's get these questions done, please. Again, look after yourself and the people around you, and try to stay positive. Okay, bye now.